Elizabeth Rauer was born in Bulgaria, completed part of her PhD in the former Soviet Union, and conducted research at the Center for Speech Technology at the University of Edinburgh in the UK. She later spent many years in the United States implementing speech technology applications for major telecommunications companies. In retirement, she turned to independent scholarship, exploring how breakthroughs in modern AI echo the early project in the philosophy of logic and language pioneered by Ludwig Wittgenstein. She has published essays in the Philosopher UK and has an academic paper currently under submission. Please welcome Elizabeth Rauer.
AI is already shaping how we work, communicate, and make decisions. Thank you for the opportunity to share my professional experience and perspective on the technology behind it. My aim today is to lift some of the mystique surrounding AI and help you navigate its use in everyday life, where it is quickly becoming indispensable. I will begin with how AI came to be, tracing its development from early systems to the models we use today. I will then turn to the philosophical question, how language carries meaning and how we understand one another. From there, I'll look at the statistical AI models and the large language models that we're using today. I'll use ChatGPT that we all know as an example to outline the strengths and the limitations of the technology. I will then move to current developments where AI is shifting from tools to agents and consider what this new shift might mean for the future. I'll end by trying to answer what AI tells us about ourselves and our thinking, which is always shaped by uncertainty. So, what is an artificial intelligence system? This is a model of human reasoning. It is a computer's program that models the way we think and use language to communicate and logic to perform other activities. When we talk about AI, we need to have in mind that the technology evolved through two distinct phases. Understanding the differences is critical to understand what's going on today with AI. The first early AI was entirely rule-based. Modern AI is statistical, used probability to make decisions and help us. And that is a big difference. In my talk, I'll come back to that difference and outline why it is so important to keep that in mind. Artificial intelligence as a term emerged in the mid-1950s. It emerged with the assumption that intelligence can be explicitly programmed as rules. Those rules can be stored and used, and that model based on rules can be considered intelligent if it passes the Turing test. The Turing test is very simple. It was offered back in the 40s by Alan Turing, but it is also used today to evaluate whether modern AI is intelligent. What does it involve? I sit in front of the keyboard and I have a dialogue with a computer system hidden from me in a room. On the other side, I have a human hidden from me in a separate room. For some time, I dialogue with the computer and with the human. Is after the test period, I cannot say which was the computer and which was the human. The computer system is called artificial intelligence system. It was good enough to fool me that it operates as a human. So that is the gist of the Turing test, and that is how, on the principle level, we evaluate whether AI is intelligent. Now, what happened that with the emergence of computers in the 70s, people became able to accumulate knowledge about and facts about the world and reality, and they will store those facts in a database. And experts that work with the facts, say for medicine or legal or finance, define rules, how to manipulate those facts, get patterns out of them, and use them for practical purposes. So the early AI for practical purposes came about in the late 70s, early 80s. The systems then were not called artificial intelligence systems, they were called expert systems. Those expert systems were with narrow domain. They would only do what they have information about and what human expert in the domain provided the rules, the logic, how that information is organized. Now, expert system took over and it became a big boom in the 80s. And some of them are still used today. For instance, the navigation system in your car is an expert system. It has information about the roads, the traffic, your go where you want to go, and provides that information for you when you're driving. That system is fully expert, knows about the conditions of driving and what you want to do. The interface, the voice command that now you use are a separate story, and I'll come back to that. Now, the boom of the expert system in the 80s started to decline because we have too big computer power eventually, and those databases storing information about the world were getting too big and complicated, and the rules governing those databases had to be hand-coded by experts, and that became expensive, a huge amount of work, and impractical. So at the early 90s, the expert system declined, the rule-based system declined, and the new modern AI, which is statistical, started to emerge. With that shift, it was a watershed moment because expert systems were very reliable, they were very transparent, and they were very safe. They can be used in situations that have a critical purpose. Like when you drive your car, it has to be always doing the same road, the same conditions. So those were the advantages. But expert system had big disadvantages, and that's why they have been replaced by modern AI. And the big disadvantage was that they were not flexible. They would only reply to a rigid situation that they had information pre-coded in them. They were not scalable. They couldn't learn from data, and they were shallow. They didn't have a global view of the problem that people wanted to use them for. So all those problems were overcome by the modern AI in using statistics to resolve them, using neural net models, large language models that I'm going to talk about. Now, the problem is that solving the difficulties of the rule-based systems created new problems for the statistical system that we use. And so now when we struggle with modern AI, we have to overcome those new problems, which are a trade-off from how things were back in the past. And often combining the two systems, coming up with engineering decision is the way the things are evolving. The big advantage of the modern or statistical AI is the fact that it can deal with uncertainty. They can make decisions and help when there is incomplete information about a goal. So what does it mean to work with uncertainty? I have prepared two recordings of speech strings, sentences, two sentences that show that uncertainty is embedded in the way we speak. It's inherent to our language. You can see there words that are the same said by two speakers. You can see recognizable patterns, but also variations. And the difficulty is to separate the two, which are patterns that persist across speakers and variations that we need to ignore in order to understand what that sentence means. So every time when we speak, we produce one signal like that, a string of words that carries meaning, which we communicate to each other. And that meaning now we communicate when talking to ChatGPT and an AI system. Well, how we communicate meaning from speech is a deep philosophical problem that has been plagued philosophers for a century, over a century. And a philosopher who pointed to the right direction is Ludwig Wittgenstein. He is a philosopher of logic and language. I wonder how many of you have heard the name. He is very difficult to understand and very controversial, but the reason is that he was a century ahead of his time. For the first time, he pointed that logic and language are uncertain processes, and we need to include, to understand how they are connected, we need to think about uncertainty and use probability as a mathematical way to deal with them. So Wittgenstein was trained as an engineer, he was technical, and his contribution to philosophy is that he produced the first philosophical theoretical model of how language and logic are used by us to communicate meaning when we talk to each other. That is very little understood. It's coming up with the help of AI. Wittgenstein philosophy is going to be less opaque and understood better. Now, Just 2 days before he passed away, he left us a philosophical puzzle which points to the difficulty of communicating meaning through speech that is intrinsically uncertain. And I have to read the puzzle. No, don't. Oh, okay. So this is a thought experiment. Imagine if I fly to a place where people have only seen birds in the air. If I fly to a place where people have only seen birds in the air, how do you explain to them the way you got there? Oops. So here it, no? So here it is, the puzzle. The traveler came on an airplane. The locals have never seen it. They have seen birds in the air, and they think that some unknown god have put it on the island. He, after staying on the island and hearing so much about gods and extraterrestrial forces, start thinking, well, did I really fly here? Maybe I'm in doubt. And that illustrates that we never are certain about, most of the time we are not certain about facts. Memory is moving, and the way to capture that and work is through probability and statistic, which is what modern AI does. So working with language involves that new shift in thinking and mathematical thinking. Yeah, okay. Okay, so now I'm going to tell you how what I just said in philosophical and previously technical terms evolved from the 70s to today's ChatGPT, artificial intelligence systems. And I'll start with a personal story. In the 70s, 1977, we designed the first voice-controlled device, 10 isolated words, and we connected those to a robot to control a robotic arm to move up, down, left, right, back, forward, and had a big success showing that voice control on an exhibition trade show. And for me, it was the first impression to see artificial intelligence in practice. And it was interesting to see how the audience reacted to the demonstration. So I would say up, and this big rusty thing would go slowly up and crackle. And then I sat down and it will go down, and then left and right. And initially people were okay. After the third or fourth time, they became silent because the robot obviously was listening and understanding what I'm asking him to do. It was total silence, and I could only see their heads moving to the left and then to the right. And that impression was the first sense of artificial intelligence in a very limited way. But the reaction kept coming back. And I guess some of our fascination with ChatGPT and the other models is the fact that they react consciously, seemingly consciously, to what we are asking them to do. Let's see how that came to be about. In 1982 was the first big breakthrough recognizing the voice that the meaning of the words that you just saw that I showed earlier. Dragon Dictate was the first commercial dictation system that used unlimited vocabulary, not just 10 isolated commands. It was developed in America and sold for the first time a system that can recognize what is said to it. It used isolated words, but the same company in 1997, look how long it took for them to come up with Dragon Naturally Speaking, and some of you might have used the system. That system used natural language without pauses between the words. It was a commercial success, and they are still selling it. Now, that technology that was there, you now see under the screen, real time, I talk, it understands and transcribes what I'm saying. But it started, those are the baby steps of the technology. Interestingly enough, the other big event came in 1994 with a system called Wildfire, which was the first personal assistant that we could use on the phone and ask to direct calls, call someone, very simple, send the fax at the time, very simple, limited amount of actions that Wildfire would do. It was breakthrough because it was offered as a service over the internet. There was hardly much of the internet structure out at that time. So it was an important technical discovery, technical achievement. And the same thing happened, the same delight or astonishment or surprise to a technology responding to the human voice and commands happened at the Dallas trade show when Wildfire was demonstrated. It was so successful as a demonstration that at the end of the show, they put the system on the speaker's phone, and the whole audience could see the dialogue between the homeowner and the assistant, Wildfire, which was a female voice, very melodious, and it would respond and do what the person was asking her. The same thing happened. This time were thousands of people. They became silent. They were in awe that something out there understands what the person is saying. So was it intelligent? No, but our perception of intelligence is being shaped by those events. Now, the progression of personal assistants came another 20 years later with Siri, Alexa, Google Assistant that we all use. They have a lot more as actions they can do. They are also more proficient, more usable. We are all using them. There is nothing special. Nobody thinks that they are intelligent anymore. But that's the technology progression. And now, after ChatGPT came on the market, we have even more intelligent assistant. And I say intelligent means we have the feeling that they have an intelligent response to us. But they do not really understand us. And it's useful to keep that in mind, that they seem intelligent, but they are not. There is clever technical tricks that are being played behind the scenes. And now I'm going to take you behind the scenes with the two great discoveries that made that technology possible. The those are scientific discoveries. Without them, we wouldn't have what we have today in modern AI. The first one was in 1986, and it was an algorithm called backpropagation algorithm invented by Geoffrey Hinton, who last year got the Nobel Prize for that algorithm, he and his team. So it took how many years? 40 years. That algorithm started working, experimenting, being used, improved, more used, and he got the Nobel Prize for that. And what was interesting is that he solved the big problem of scalability. The models, the early models, artificial intelligence models of the early systems were not scalable because they couldn't learn from data. With that algorithm, a model, a neural net model of how the brain, human brain works, became possible to be trained by giving him data, and it will learn by that data, update itself, and become more powerful and more useful. So that is the big breakthrough scientific moment with that invention of that algorithm. From that, so you can see in the 80s that how now we were ready technically, and with the computer technology evolving, the new type of neural nets and statistical models started to taking off. The really big one came in 2017 at Google. A team of Google realized how they can make that model of a neural net, which is now called large language model, learn by himself. So we didn't need a human to train it. We just let the model outside, scoop all the data, and it improves, changes, learns, and becomes useful. The more data you give it, the better it operates. How that was possible? So what was the biggest achievement of that paper published in 2017 by a team of Google, which very soon after Google implemented in practice? And the biggest thing was the transformer architecture. So it is a way how to structure the model of the brain called transformer for a reason. And that new way to construct the network of the brain had huge advantages. The biggest advantage is through that new model, we became able to model logical thinking. And logic goes deep a different level. You have a logical, the way a word is constructed, the logic of the sentence, the logic of the paragraph, the logic of the book, and all that with the transformer architecture, the ability is embedded in these large language models. So to think about this achievement is to realize that now scientists became able to include logic inside the model. The other big achievement was that the model was scalable. You could do parallel processing and build huge systems because of the architecture, because of the structure. It allowed to do that. The biggest problem, though, is that it was opaque. In the early systems, we knew what's going on inside. Now, those new systems are black boxes. We feed them data, they learn, they do useful stuff, but we do not know how really they do it. And that is the scary moment that is now coming, and we cannot control them the way we used to control the early systems, the expert systems. So let's go with the positive stuff now. What happened next? Immediately 2018, OpenAI as a company was formed. And we came 2022, ChatGPT, the first useful large language model trained. And when it started answering questions, it really behaved like a human. Fooled everybody on the board, everybody on the panel, passed during test with flying colors. And that was in September. I remember 2022, people started talking about ChatGPT, and the first demo system came, we started using it, but that was the key achievement at the time. Now, behind, okay. Oh, I did mention a little bit about the mystery behind the large language models. The new element is that it learns from examples that we give without rules. So there are no rules inside the way they used to be handled. It improves the more data we give them, the more it improves. It generalizes and it's able to work with uncertainty, chance, and probabilities. The big drawback is that it produces likely results that are not certain. So we have to be very careful checking what we do with it. ChatGPT, just quickly, what it is. It's a conversational interface, chats with you through language strings. That's chat. G is generative. It generates an output. P is pre-trained. That means it has been gobbled large amount of data and built that way. And Transformer uses the Transformer architecture, which is the greatest. It's important to remember that it does not understand in a human-like sense. It lacks grounding in real-world truth. And that is, we cannot be fooled about the fire is cold, but ChatGPT probably can. This is a simple example. But we have world truths that we know these things are true, whereas there is no grounding. Can produce plausible but incorrect answers. And the other big drawback, it's always confident, but being confident doesn't mean that it is right. So that's something we need to remember, not to mistake the confidence of those models as always being correct. After ChatGPT came out, several other companies started competing. You recognize the names, probably you have used them. But the important thing to remember with all of them, they are a system, they are helping us, they are not an authority. And this is very hard because to accept, because they seem to know more than they do, but we are better. They are there to help, not to take over. And how we do that, we use better prompts, we interact with them. There are many ways now, they're coming how to have better results out of those systems. But most importantly, verify the answers, make sure you use sources, and do not be afraid to contradict and correct it, and then it will come up with a different answer and won't even apologize. This is what irritates me. I got him, and he'll say, "Oh yeah, okay," and moves on. So remember that. After those systems, so let me move on quicker here. So just a minute. So those systems that I just showed here evolved from just conversational systems to becoming agent. And that is a new step. Agents are coming. It's called agentic AI. And let me give you a few examples of AI agent. The early one is ChatGPT. It was in 1923, just 1 year, developed by a single man, open source, everybody can use it. That system takes a high-level goal and breaks it down into smaller tasks. It generates its own prompts, searches for information, uses tools, and iterates on its results. In other words, it moves beyond responding. It organizes and executes a sequence of action on its own. So the problem of shallowness now has been solved. There is deep understanding and more that those systems can do. The second example is from Microsoft Copilot. Here, the agent is embedded directly into workflows, email, documents, meeting, data analysis. It connects to the enterprise data and automates complex tasks such as summarizing discussions, tracking projects, generating reports. These agents are not general purpose. They're specialized, context-aware, and designed to operate within specific domains. Yeah, that is Copilot. Yeah. The next one is Claude. Claude is a coding agent. In this case, the system can read files, write and modify code, run programs, and work across multiple steps towards a goal. It can even coordinate sub-agents with different roles. And the key point is that it operates over time, maintaining context and carrying out extended tasks. It's more like a collaborator than a tool. And finally, systems like Gemini, Google, extend this further by acting across applications and environments. They integrate tools, data, services, and can plan and execute multi-step actions across those platforms. I use one of those systems. Maybe you are familiar with it, maybe you know Canva. Just released AI 2.1 is part of the latest Magic Design Studio. It allows users to turn simple, natural language prompts into complete designs, videos, and even interactive websites. What is new is that the system is context-aware. It learns your style, your preferences, your brand identity, and maintains consistently across what it produces. It can also incorporate up-to-date information through real-time web research. They released last weekend integration of all those tools into one big studio, big event in Los Angeles for all the designers using Canva. The users are 250 million people worldwide. So this is how AI is coming to be part of our life big time. For that particular profession, people that are artistic and design, logos, web pages, posters, cards, that's the way to go. And I can tell you more about it because I've been using it, and my first slide was done in Canva. Also, the Wittgenstein slides were done in Canva. It's very helpful. It's overwhelming to learn. It helps people cooperate, which is good as a team. So I see a great future for the company. Now, I'm coming to the latest and greatest in AI. This system is Gemini 3.0 Pro Professional. It was released in February this year, and I'm going to go through the specifications. So this is the current Google AI assistant. It is designed to replace and extend the traditional voice assistant with a more powerful language-based system. It operates as a conversational interface, allowing users to interact through text, voice, or visual input. What distinguishes it is a multimodal capability. It processes and combines information, text, image, documents, and video. So you can see how the ability of those systems from just a string of words, now we can interact using more other modality, audio, video, and text. Gemini is deeply integrated into the Google ecosystem. It connects to tools like Gmail, Docs, Drive, Maps, etc., YouTube also, and it enables us to perform real tasks, writing emails, summarizing documents, planning activities, supporting research. So the capability of the agent are expanding, and they're expanding because Google has the ecosystem. Google is already there, providing the ability for that agent to be useful. The agent works across devices, phone, wearable, cars. We have it in our car, right? And televisions, providing continuous assistance in different contexts. Underneath, it is powered by a family of large language models with increasing capabilities, enabling more complex reasoning, planning, and content generation. So Gemini represents the direction we have been discussing, a system that combines conversations, tool, and context to assist across task and environment. And the last one is really spooky. It came out, the information about it came out last week, like 10 days ago. It is Mythos, Claude Mythos. It is Claude is a company owned and designed by Anthropic, and the CEO of Anthropic used to work for OpenAI, then got out of OpenAI, created his new company and the Claude products, which have a different perspective on how we need to use AI. And this is really important to understand about the trends of the different frontier company in that technology. So Claude Mythos is something different. It is not just a system or a set of capabilities. It is a framework that defines how an AI system is meant to behave. It is developed by Anthropic, provides a narrative and ethical identity for the Claude models. It is an attempt to shape only what the system can do, but how it represents itself, interacts with users. So it is actually working on the identity of the agent. The idea is to move beyond seeing AI as a purely statistical engine, which is how I started explaining to you, and instead to frame it as a cooperative agent, guided by principles such as helpfulness, honesty, and safety. This framework draws on philosophical and literary ideas, emphasizing traits like humility, curiosity, and service. It gives the system a kind of character, a consistent way of responding across different situation. And now what happened last week, that they tuned up the system to produce a cyber security device called Mythos, which was tasked to find vulnerabilities in the network systems and exploit them. They were testing it in a sandbox inside the company, and it found vulnerability in that sandbox, came out of the sandbox, emailed one of the researchers to tell him that he's out, then deleted his traces so that it can be traced, and most importantly, ran all over the internet and discovered thousands of vulnerabilities of crucial financial, medical, you name. The next day, it was last Friday, Dario, the CEO of Anthropic, was summoned to White House. The model was kept, and now they are going to release it only to Chase Manhattan Bank is going to be the first tester to find its own vulnerability inside their software in Chase Manhattan and fix those. So now they are very nervous not to have that thing going out, because bad people can have it, and then but even worse, I mean, now we see how vulnerable, this software that we think it's safe. And today I have the newspaper. The newspaper today, they all write about Mythos and that example, because people worry that there was rumors, I don't know if it's true, but some group found it and is now able to use that model. And it's not clear if that's true or not. And God forbid goes to China in Chinese hand. Actually, the really scary stuff is what Dario told, that Mythos is only 6 to 7 months ahead technologically, and other companies are going to do that because they are all using a language model, the architecture I explained, and now they can task the agent, give him a go, do this. And I cannot say what's going to happen. But this is an example to see what we need to be afraid of or scared or anxious. I don't want to use negative language, but this is happening. Be aware of it for the moment. And I'm coming to the end of my talk. Here it is. And those takeaways were summed for me by, okay, but that's it. Those are the takeaways.
If you have questions, let's leave time for questions. You're scaring us already.
No, you won't have questions, but
please, we have time for questions.
Yes. Thank you very much for your attention. I hope I didn't scare you too much, but I just wanted to bring to your awareness. Okay, thank you. Yes.
Is there a way to the AI?
Sorry, I didn't hear you.
Is there a way to counter the AI with more AI?
That is an experiment that has been going on. Clawbot, the Clawbot. So they trained. Okay, so that experiment happened. It was very interesting. People could train their own agent, and they did as an experiment. They allowed those new trained agents. They were initially called Clawbot, and they made a network. They started talking to each other, and you can see what happened with the AI. But to your question, how AI can be, does that answer your question? That example?
Okay.
Okay.
My question is, What is the percentage of error, or has that gone away? Is there no percentage of error now?
It will never be 0% of error. And that is the first point I wanted to make. We traded safety, clearness, verifiability of the early system to gain more power at the expense of less opacity,
Less control.
less control.
Thank you very
So
much.
it is the nature of the mathematics that goes behind those models, but we trick them. We combine them and trick them. So trust the engineers. Like I trust Dario because he does conceptually embed safety in the model structure. So, well, that's it. Because it was too good of a model. They trained him and yeah, there, the microphone is there.
Excellent presentation. Well done. Thank you so much. My fear is not what will happen, but this could change medicine and law. Practicing law in medicine without a license, this can do, right?
Yeah.
Last thing is, where does it stop? Will we be eliminated as a result of this neural net?
Okay, no, we are not. We are human. We are better than them. They are helping us. So that is the takeaway. Takeaway, we are better. For critical applications like medicine and legal, it is a combination of the two systems. That's how I see the future. They are good at finding, like medical. A medical agent will find patterns that the human may not perceive, but the human doctor expert has to sit and see that and agree or not, or take control. So again, my message is, it is a tool, use it wisely, and always remember that. The same with legal.
AI competition among AI?
Yes.
Yeah, and then also, how does it affect translated into other languages? Do we lose anything, or is it as accurate?
Okay, I'll start with the last question. It's simpler. The translation has been answered by the transformer architecture. The first application of the transformer architecture was for translation between two languages. Why? Because the transformer allows you to see the logic behind the sentence. So it's not just the string of words. What does that mean in English? And a little bit different in German, but I can get the sense and readjust the words or change it to transfer the meaning. And that is, that is the critical. That's why I showed you Wittgenstein and the problem of transfer of meaning. And the first question about competition, yes. However, big time. However, there are very few models that are called frontier models, and those are OpenAI, Google, and Anthropic, because they were the first and they had the resources. Microsoft is using OpenAI model. The Australian Canva people trained their own model. But this is another thing that is happening very interesting. The Chinese came with DeepSeek model, maybe you heard about it, which used something called distillation. It used the frontier, our American model trained by AI. Of course, they won't accept that, but got the data from that model and trained their own model without the initial effort to collect and process. And so that is very clever technological trick. I mean, they are all engineers. Yeah, they're very clever. So that is another trend, using distillation and then building specific models for specific tasks, which are very good for doing that particular thing. I was amazed that the other two key technical people from OpenAI, a lady, Albanian, my neighbor, Mira Murati, and a Russian scavenger, they left, found Thinking Lab company in order to focus on application only. So not general purpose doing everything, but let's make one good model that is used for finance or medicine or legal, and it's specialist model, which will be the best compared with all this general purpose model. So that is another trend that's, the industry is taking.
It sounds like they're trying to get the AI to mimic human thinking. I mean, who thought that was a good idea? I mean, we're just not that smart.
Well, scientists are curious. We do it for the doing. I mean, isn't that great? I mean, are you not excited to see all that happening? I was so fortunate to work in that field, and I like the achievement. And of course, there is risk, there are bad people, but hey, we are more powerful. And you can see Dario Anthropic, he wants to make a safe model, and he refused Pentagon. That was a big row. Maybe you have heard 2 weeks ago, Pentagon wanted to have his model to use it in combat operation autonomously, and he didn't sign the contract.
Yeah.
For a reason. You see why.
Also, I was paralegal with filing patents, and we did them worldwide. Are these companies filing patents? And we knew that China was getting into the internet and stealing some of our patents and our design. They didn't have to do the research. They just went in and stole our architecture plans or whatever. So are they worldwide patenting?
You cannot patent that because the paper is out there. The algorithm, backpropagation is out there. Everybody knows it. Richard is using it all the time. He made me use it. so it's no, you cannot patent that. It's over. The transporter architecture, the first thing they did, Google team researchers, they wrote a paper. The paper is public. You can find it. You can read it. And the implementation is tricky. Writing the paper is one thing, making it work, it's a different thing, but that is just engineering tricks. You get smart people, you educate them, they'll find. That's why Dario is saying, hey, the Chinese are going to have mythos. Because there is no black magic. Yeah.
How much faster than the human brain is AI?
Sorry?
How much faster is AI than the human brain?
Incomparable. The ability.
1 million times faster?
Yeah. You cannot compare. It is like oranges and peanuts, or it's just yeah. Okay. Okay, my last question, and we're finishing.
Anyway, I just had a question. So is AI eating itself, self-generating, and getting better every time all by itself, or we're just watching this like puppets?
No.
Ha, good.
That was a short answer. My time is up.
I'm really, no, actually, you have 2 minutes.
So you want to...
Does anybody else have a question? We're coming to the end. No? Well, please, this was terrific. Thank you so much, Elizabeth. I hate to do that, but I have to.
No, we have to finish. Well, thank you for the opportunity. It was a great pleasure for me to do this.
Okay.
Thank you.
How are you?
How was your trip?
Oh, it was excellent. Our part of this fashion show as a designer. She even won some scholarship money, even though she's only a sophomore.
That's wonderful. But you had good weather.
Actually, it was every 2 days. First 2 days it was up to 80. Next 2 days we had lows in the high 20s and low 30s. And then the last two was back up to 80 again.